Hello guys, welcome to another video lecture. This time around is the chapter on air and atmosphere. Okay, as I was saying, I think in the previous video lecture on ammonia, okay, why Mr. Chen and myself are doing these video lectures is because we find that these two topics are very content driven. So we just want to cut time short and just put the videos online, and so that you can just listen to me talk, and then after that, once you're done with the videos, if you need to copy anything that is on this slide, then you can just copy on the textbook. Okay, you can pause and then copy whatever that's written here. So without further ado, this topic is going to be slightly longer, not slightly, I think much longer than the previous topic on ammonia. Okay, so let's start off with the quality of our air. Now, especially that the coming of the haze, what can you say about the quality of our air? I think it leaves much to be desired. Okay, and basically, what are some of the pollutants produced by motor vehicles? How are they produced and how do they affect our health? So these are the kind of questions that we will tackle in this chapter. Okay, so moving on. If you look outside, I'm not so sure what happens now if you look outside of your room as you are listening to this video lecture. Most probably, if you are, when I'm doing this video, I can't see anything outside because it's very hazy. Okay, so does it appear clean, or does it look clear, or does it look and smell bad? So I mean, in our region where we're surrounded by our neighbors, Indonesia, Malaysia, South China Sea, whatever you have, okay, whatever that our neighbors do, or whatever that we do for that matter, okay, we are affected. So anything that they do, for example, the haze, it's widely known that the Indonesia farmers burn a lot of stuff. Okay, they wanted to clear their land, so that's why whatever they burn, the fumes and all that, they spread over, the wind carried over to Singapore and Malaysia, and that's how we are affected. Okay, so in earlier chapters we can actually see that chemistry has brought us benefits, but in this chapter most likely we'll look at some of the harm that actually human race has done. Okay, and it results from the use of chemical knowledge. Okay, so as I was saying, what we have done is at our power station, burning of fuels contribute to air pollution, and then leading to health problems and environmental problems as well. Okay, so when we talk about the atmosphere, okay, let's just brief recap. The Earth is surrounded by a layer of air that's about 8 kilometers thick, and that is what is called the atmosphere. And as you all know by now, air is a mixture of gases. So the main component of gases are nitrogen and oxygen. Of course, high up in the atmosphere, the main component of air is made out of nitrogen. Okay, but back in the near ground level, okay, we have a lot of oxygen. Okay, and of course, those are not the only gases. You have carbon dioxide as well as your noble gases. Okay, so your other gases that are part of air are also carbon dioxide, water vapor, and as I was saying, noble gases. Okay, now think time. What do you think the clouds consist of, and how are they formed? Okay, without further ado, I'm just going to give you the answers, because if I'm going to wait for a very, very long time. Nobody's going to answer me. Okay, basically, by now you all should know that clouds consist of fine water droplets. Okay, and they are formed actually by the condensation of water vapor when your water from the sea evaporates. Okay, that's how you go. So this is FYI. I don't think it will come out in a chemistry exam. I'm not so sure about other exams for that matter. Okay, now a common MCQ question for air and atmosphere is this, where you have an experiment to find the percentage of oxygen in the air. So basically they will give you gas range. It depends. Sometimes they'll give you 1 gas range, sometimes they'll give you 2. In this case they'll give you 2 gas ranges, and in this experiment, between the 2 gas ranges there is a heat resistant glass tube filled with copper powder. Now what this experiment aims to achieve is basically, if they know that inside the glass tube there is oxygen, They want to know how many percentage of oxygen will react with the copper powder. Now, when the copper powder is being heated up strongly, it will react with oxygen gas, and then it will form copper oxide. Now, let me play the animation. Okay, let's see whether it can work. Okay. Oh, it can't. Alright, so the animation can't work. Okay, now it's okay. So basically what you will actually see is the air in the syringes will pass back and forth over the hot copper until there is no further change. So if you would just like to use your imagination for that matter, okay, let me see. Oh no, I can't do it. I can't play the animation. It's okay. So you just imagine. So it's not like a ghost where the gas syringe just move back and forth until there's no further change. Now what is actually happening is when you heat up strongly, the copper powder will actually react with the oxygen gas to form copper oxide. Okay, so as I was saying, the oxygen in the air combines with hot copper to form black copper 2 oxide. This is the equation. Okay, and what you will see is the volume of the gas in the syringes actually decrease. Why? Because the oxygen will react with the copper. But now, will it decrease totally? Of course, the answer is no, because your main component of oxygen, okay, is the main component, the component of oxygen in the air is not 100%. Okay, so basically, if you want to find how much percentage of oxygen in the air, you just take the initial volume of air in the syringe minus the final volume of gas in the syringe. Okay, and then you will arrive at the final answer. Okay, so this is just basic common sense. You don't need to actually figure this out. Okay, right. So yep, that's how you find. This is a common MCQ question that will come out in your prelim exams and your national exams. Okay, so for example, if let's say I'll give you an example here. If the initial volume of the air is 80 cm3, then after you do the experiment, the gas syringe pass back and forth. Then in the end, you'll end up with having 64 cm3 of gas. So basically, what is the percentage of oxygen in the air? So it's fairly simple. You just take the difference, 80 minus 64, divide by the original volume, okay, times 100%. That's it. Then you'll find that it's 20%. Okay, easy stuff. Right. So you will learn that in this chapter, whatever that we've learned, dry air is 79% nitrogen, 20% oxygen, and 1% by other gases by volume. And the other gases, of course, consist of carbon dioxide and noble gases such as argon and stuff like that. Okay, then we'll talk about combustion. Now, I'm very sure that Mr. Chen and myself, when we conduct our lessons, we always tell you that for combustion, it just amounts to reacting with oxygen. So, when we say that many substances react with oxygen, okay, it is an exothermic reaction. It is also called combustion. Now, if flames are being given out during combustion, it is called burning. Okay, so another name for combustion is called burning. And many fuels will contain hydrocarbons. Okay, so when you learn later on in the topic on fuels, when hydrocarbons, okay, like methane, burn in oxygen, okay, or combust in oxygen, they will only form carbon dioxide and water, nothing else. Okay, now that is if let's say you have a lot of oxygen gas. Now what if you have very little oxygen gas? Now if you have a shortage of oxygen gas, your carbon can only burn to form carbon monoxide. Okay, but still there is water. Okay, oops. Right, slight mishap there. Okay, so you will have, instead of carbon dioxide, you will get carbon monoxide and then water vapor. Okay, now if very little oxygen is available, your carbon does not combine with any oxygen. So basically what happens is your carbon will become a vapor form, and that vapor form, when it condenses, it forms this black solid called soot. So guys, when you all go for your barbecue, alright, you put your face over the barbecue and then your face becomes chao ta. That is soot. That is not carbon monoxide or carbon dioxide. Now what happens is, because your barbecue pit inside the barbecue pit has very little oxygen left. Okay, no doubt there's a lot of oxygen entering and going and stuff like that, but at that moment of time, a lot of soot is being given out because there is very little oxygen in that small confines of the pit. That's why you get soot. Okay, now think time. I said we usually heat things with the air hole of a Bunsen burner open. Give two advantages of this. Now, as you know, if you leave the air hole open, basically your flame is cleaner, no soot, okay, so no smoke, and your temperature of the flame, because there's an abundance of oxygen gas, it is hotter. Okay, so those are the two advantages of it. Now, combustion in the Bunsen burner. Okay, so basically when you open up the air hole, okay, you get a pale blue flame, where it indicates that your gas is burning completely. Okay, because your gas is receiving plenty of oxygen. Okay, now if let's say you close up the air hole, okay, you will get a yellow flame. Why? Because of with tiny specks of hot soot. Okay, why? Because your gas is receiving insufficient air. So that's why when you on your Bunsen burner for your spa, okay, it is always recommended that you open up the air hole, let some oxygen gas in, and then you will see a very strong blue flame. Okay, a non-luminous flame. Now, combustion in air. Combustion is rarely complete when carbon compounds burn in air. So, for example, candles and wood. Okay, when they burn, they always burn very cleanly. Okay, they always burn in an incomplete manner. Why? Because there is a lack of oxygen at that point of time. So usually carbon monoxide and soot are produced, which causes air pollution. Now, let's say for example, when you have a household gas cookers, okay, a gas burner needs a clean flame so that poisonous carbon monoxide gas is not formed. Okay, and most of the time pots are not covered with soot. Okay, why? Because last time when you have a household gas cookers, it is very problematic. The surface of the gas cookers will eventually become black. So that is a problem for a lot of housewives nowadays. So how do you ensure a clean flame? Now, for that, there must be a good supply of air so that the gas in the burner is burned completely. Okay, so that's why it is structured in such a way that, okay, the gas has a lot of air, okay, entering through the burner. Okay, so that you have a very good blue flame, and then you can cook your food nice and fast. Right? Okay, so what is air pollution then? We've already talked about complete combustion of substances and incomplete combustion. Basically, air pollution is when your presence of substances in the atmosphere that are harmful to living things and to the environment that contributes to air pollution. Now, there are certain gases that are considered as air pollutants. Okay, so you call these substances air pollutants, and there are six main air pollutants in your syllabus. Okay, the first one is sulfur dioxide. Number 2, nitrogen dioxides. Number 3, carbon monoxide. Number 4, methane. Number 5, unburned hydrocarbons. And number 6, ozone layer. Okay. So how much do you know about each of these pollutants? Now, I think if let's say you are talking about number 1, number 2, and number 3, you will probably have known it a lot by now. Okay, as you know, sulfur dioxide and nitrogen oxides are acidic gases. Okay, acidic oxides. You learn that in the topic on bases. And carbon monoxide is a neutral oxide. Not so much for methane and unburned hydrocarbons, because you all have not learned about organic chem yet. And of course, not so much about ozone. All of you know that ozone is a good thing, because ozone shields the earth from the UV rays of the sun. Okay, but